Hello, advanced algebra students, and welcome back to another video lesson as we continue to explore logarithmic functions. Now, yesterday you did some exploration on trying to figure out how logarithmic functions work and solve. Those of you that joined the live session on Thursday will have a little bit of an advantage to this today. Those of you that haven't, you might want to just pause the video and come back to this after you've attended today's live session. It might make more sense after you've attended the live session, okay? And it'll just, you gotta trust me that it'll make more sense after you've seen and done a little bit with me in that live session. So here's that big idea. Logarithmic functions and exponential functions are inverses of each other. That allows us or gives us the ability to solve equations where the exponent is x. And there will be a lot to come on that later on. All right, but that's really what we're trying to get at, is so that we can solve problems where 3 to the power of x equals 1,000,000. Trying to figure out how we might be able to solve that, okay? So from yesterday, from those of you that have, if you've already attended the live session, you should be able to do this slide. So pause the video and try to rewrite these in exponential form. All right, letter A. Remember, we talked about if there's nothing down here, that it's a base 10, common base. So we write it as 10 to the power of x equals 100,000. In other words, 10 to what power would give us 10,000? And thus we can find what that answer would be. All right, but remember, if there's nothing there, if there's not a base number, the base is 10. Letter B, 7 to the power of x equals 1,608.07. And we could figure out what that is. I think x equals 5 in this case, or something like that. So that would equal 5. And then this one's a little bit trickier, but 2 to the power of x equals 1/64th. 2 to the power of x equals 1/64th. And again, that'll allow us to then figure out 2 to what power. Well, anytime that this goes and turns into a fraction, x is going to have to be a negative value, negative something. And in this case, 2, 4, 8, 16, 32, so 6 would be 64. 2 to the 6th is 64, but to move it to the bottom means it was a negative. But the main goal in solving is being able to go back and forth between logarithmic functions and exponential. Can you write them both ways? Because this is really what we have to do to solve. We have to go back and forth between the two formats. All right, and that's what solving is it allows us to go back and forth. So as you solve for x, right, the log of some x is 3/4. We first should change the problem from log form into exponential form. So just like we did on that warm-up. Well, once again, I don't have a base here, so this is base 10, which means 10 to the 3/4 power equals x. And then we want to calculate, what is 10 to the 3/4 power? 10 to the 3/4. Well, we're going to have to use our trusty friend Desmos to help us figure that out. 10 to the power of, I'm going to put it in parentheses, 3/4. 5.62. 5.62 would equal x. I can only solve that x if I converted it into exponential form. Same thing here for letter B. We want to convert it to exponential. There's no number, so that means the base is 10 to the power of that opposite side equals this side, x. 10 to the first equals x, which means 10 is equal to x. 10 is equal to x. So that process of converting it to exponential, hopefully you're understanding and seeing how important that is. Why don't you try these three? Might be a little bit trickier at first, but see what you get for these two. These two. All right. Let's look at this one. The base is 81 to the 5/4 power equals A. So we can figure out what is 81 to the 5/4 power. If I clear this, 81 to the 5/4 power is 243. 243 would equal my A value. Letter B uses quite a bit of information from our previous chapters. We start out with base of z, and we raise it to the opposite side. Z to the 3/4 equals 8. What is my process then to get z by itself? We raise this whole thing to the reciprocal, 4/3. If I do that on one side, I have to do that to the other, 4/3, which means we are looking for what is 8 to the 4/3. Remember, this was the cubic root of 8, then whatever answer we got to the 4th power, or 2 to the 4th, which is 16. Okay, but again, if you can figure out how to change these from log form into exponential form, it makes trying to figure out how to solve them or punching them even into a calculator, 8 to the 4/3, we'll just double check our answer. 8 to the 4/3 is 16. It makes solving them so much easier if you can change them to exponential. Here's 3 more. Why don't you try these 3? See if you can't record what do you get for an answer. All right, letter A. 16 is our base to the 3/4 power equals A. And again, this means the 4th root of 16, whatever answer that is, to the 3rd power. Well, the 4th root of 16 is 2, and 2 to the 3rd is 8, or 8 equals the value of A. So A equals 8 in that log. Log x equals -2. That means we have a base of 10, and 10 to the -2 would equal x. What was our rule for negative exponents? Well, we had to move it to the bottom and then turn the exponent to a +2, or 1 over 100 equals x. 1 over 100. Finally, letter C. Once again, our base is 10 because we don't have any numbers, so it's a base of 10 to the opposite side's power. So 10 to the 4th equals x, and 10 to the 4th is a 1 followed by 4 zeros, or 10,000. 10,000 would equal x. So hopefully, again, I'm trying to stress this, but we have to be able to convert log functions, log forms, into exponential form in order for us to use a lot of our skills to solve. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay